Hello, I'm Christopher Nzediego, a postdoctoral researcher at the University of Alberta. I work with Professor Scott Chang and Professor Ann Nate. In our lab, agricultural wastes such as canola straw are converted to carbon-rich materials. These materials would be used to treat wastewater. When fully developed, these materials will help reduce the threats posed by wastewater and contaminants in the environment. Thank you.
Hi everyone, my name is Catherine Tays. I am the Research Communications Coordinator at Future Energy Systems, and I also have a PhD in microbiology and biotechnology. So when I was in my PhD, one of the main things that I did was study the growth and the optimization of the growth of bacteria. The bacteria that I worked on were called methanotrophs, or methane-eating. So they naturally used methane, a potent greenhouse gas, as their carbon and energy source. So what we were trying to do is look at how do we grow these bacteria better and induce them to create useful value-added products from the methane that they're eating. For instance, biodegradable bioplastics and biofuels. From this research, we can actually turn negative things, the production of methane from industry, into positive, useful products for us that we use in our everyday lives.
This is a photograph of a field station in Professor Jeffrey Gu's research. This is a completed seismic station site. The solar panel is on one side, followed by two buried vaults. In one, there's a seismometer, an instrument for detecting ground motion for earthquakes and any small movements. The other contains all the wires, a rechargeable battery, and a computer to acquire and record the data. The battery is charged by the solar panel, which allows the instruments inside the vault to function all year long. But how does this relate to energy? Meeting the global challenge of reducing greenhouse gases requires safe and effective carbon dioxide sequestration, or trapping and storage. A key part of trapping and storing carbon dioxide is the ability to monitor structural changes to the areas where carbon dioxide is stored, which is generally underground. One way to do this is through seismic monitoring, which continually collects signals from earthquakes and other cultural and industrial sources, as well as possible ground motion associated with these storage sites. Passive seismic imaging has been successfully used in detecting both induced and natural earthquakes. It has been also used to monitor carbon dioxide injection sites in recent years. But the scope and application of passive seismics in Alberta remains in its infancy, and that is what this lab is studying. Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.